This video is going to review what we did at the end of the lesson for 5.1, 5.7. It was actually the second day. Day 1 we talked about how we graph parabolas in all three forms, and there was already a video that reviewed that. This video is going to talk about the two topics we did on that day, which is systems of quadratic inequalities and word problem applications. And what I decided to do, rather than come up with brand new problems, is I pulled two of the slides from the class notes. So when you look at these problems, they should look familiar, but I think if we go through them the second time, you get to see and hear how we did them the second time. Maybe they will make a little more sense and help you prepare for this quiz. So what you're being asked to do here is you're asked to graph this system. We're going to use our calculator many times to help us, and we'll talk about what the calculator does for us. When you go to graph these, the first thing you want to do is think about what form it's in, because if you can identify the form, then you can identify what process to graph it. If you look at the first one, the one right here, this is standard form, and the way I know it's standard form is because there are no parentheses. Standard form is probably the easiest to recognize because it has the absence of any parentheses. When you're dealing with standard form, your formula to find the vertex is that the x value is always the opposite of b over 2a. So when we look at this problem, keep in mind your a, b, and c. A stands for whatever is in front of x squared. It's the coefficient of x squared. B is the coefficient of x, and c is your constant value. In this case, there is no b value of this one. If you look, there's an x squared term, so we have an a value, but there is no x term. So for this one, my b is 0, and 0 divided by anything is going to be 0. So we know that my vertex for this first one has got to have an x value of 0. For the second one, I'm going to number this, put a little 1 next to it, just to help us remember which vertex is which, since we are going to have two of them. My second equation, inequality, is not in standard form. This is vertex form. Vertex form is easier to work with. You don't have a formula you have to memorize. All you have to do is figure out the vertex from looking here. Inside parentheses, your vertex is going to be the opposite of whatever is in there. So instead of a negative 1, it will be a positive 1. And then comma, whatever number is out here. We're going to type both of them into our calculator, and so we can get an idea of not only to help us with the vertex and guarantee that we did things right, but also get an idea about shading and making sure we have everything looking the way we want it. So we're going to go into y equals. Whatever you have in y equals, you can get rid of it. You're going to type in that first inequality, the negative x squared plus 3. You're going to type in your second inequality, which is 3, and make sure you use parentheses in the same place that it is in the problem, 3x minus 1 squared minus 5. Even before I hit graph, the one thing I want to think about is I know that top inequality, that top parabola, is going to open down because it has a negative in front of the x squared. I know the second one is going to open up, so I already have a decent idea of what it's going to look like. When I go to graph this, because I'm not sure what the last thing we would have graphed together is, I'm going to do zoom 6. What that does is it gives it back to the basic window. So here's my first parabola. It does open down. There is my second parabola. It does open up. I haven't found the vertex yet for the first parabola. Now, I could very easily just plug 0 in by hand and get it very quickly, but I also want to remind you how we did on the calculator. If you hit the trace button, up in the upper left-hand corner, it will tell you which particular equation it's on. It's on the negative x squared plus 3, which is what we want. If we want to be on the other equation, working with that, we can use the up or down arrow, and it'll flip back and forth, and you can see every time I do that, it flips between it. I want to work with the negative x squared plus 3. I want to know what happens when I plug 0 in. So if I hit 0, enter, it will tell us. It happens to be where the cursor already was to begin with, but if it's not, you can type in any value you want. So there's my vertex. My vertex is at 0, 3. If I want to double check the other one, maybe I'm not sure if I did my vertex right there, I can hit the down arrow to get to the other one. I'm going to type in a 1 and make sure it is flashing at the vertex, which is 1, negative 5, so I'm definitely right on my vertices. I want to check out my shading, so the way I'm going to do that, if I go to y equals, you're going to go over to the icon to the left of the y1. Less than, which is the first one, you want the lower right triangle, so you just hit enter. It's about 3 times, I believe. That is your less than shading, and then if you go to the next one, we want greater than. Greater than is the little upper right-hand triangle. I'm going to hit graph again. So there's my first parabola. There's my second parabola, and my shading, my answer is the shading that overlaps. The calculator makes it look almost like a checkerboard pattern. It's where those two shadings overlap. So what I want to draw on my graph now is I want to graph the vertices. I want to make sure I have an opening up or down the correct way, and then I'm going to fit my shading at the end. So first one, my vertex is at 0, 3. It is opening down. It is going to be solid because it has the or equal to, so I'm going to graph it like this. I'm not going to get real picky about how wide you make it. I'm not going to make you be really specific. It should be generally close to what you see on your calculator. Then I'm going to graph 1, -5. This parabola opens up. It is also solid because it has 0 or equal to, so I don't have to worry about making any dotted parabolas here. And I'm going to graph this one. This one's going to be a little skinnier because the coefficient is 3. And then finally, I'm going to shade, just like the calculator did. My feasible region is what this is called, is this overlapping shading area in between the two parabolas. What that tells me is all the points that are in that shaded region make both inequalities true. The other thing that we did on the second day of this lesson is we talked about how we can use equations that represent parabolas to answer word problems, real-life applications. So we did this problem in class. It was like the very first one we did when we talked about applications. And it has a quadratic equation. The way I know it's a quadratic equation is it has an x squared. And it's asking us to use this equation to determine what temperature, and temperature in this case is going to be your x value. It tells you that x is your temperature, is going to make the most people feel comfortable. This formula is talking about the percent of people that feel comfortable at a particular temperature. So the first thing you want to do with these is, again, figure out what form it's in. So if you look at it, there are no parentheses, so this is definitely standard form. The next thing we need to do is find the vertex. The vertex in this case isn't going to be necessarily what we care about visually, but it's going to have a purpose. It's going to have a meaning, and we'll talk about that in a second. First, let's find our vertex. Since it's in standard form, my formula is opposite of b over 2a. B is 527.3, so I'm going to have negative 527.3 divided by 2 times a. This is my a value. I'm going to put it in parentheses to remind you that it's really important you put a parentheses in your calculator. So now I'm going to go to my calculator, and I'm going to type in, we can quit out of this, I'm going to type in negative 527.3 divided by parentheses 2 times negative 3.678. Have to put that in parentheses in order for the calculator to put both things in the denominator. Hit enter. My answer, I'm going to go out 3 decimal places, so I'm going to write 71.683. That is your x value of your vertex. What that means in this case, if you think about your parabola, I definitely know this is a parabola that opens down. So if you think about a parabola that opens down, again, I know it opens down because it does have a negative in the first code of coefficient. That tells me that wherever that vertex is, that is going to give me what's called a maximum value. And that's what this question is asking for, the temperature that the most people felt comfortable. So it's asking for a maximum value. So the temperature that the most people felt comfortable with was a temperature of 70, just over 71, between 71 and 72 degrees Fahrenheit, which is a very possible answer. You want to make sure your answer is logical, and it is logical that people feel comfortable at a temperature around 72 degrees. Now the rest of this question said at what percent felt comfortable. That's the y value. That means if my vertex is 71.683 for the x, I need to figure out the y value. The y value gives me the percent that are going to feel comfortable. So is it going to be 50% of people, or 60, or 70? There's a couple ways to do this. You could either by hand, using your calculator, but typing it in, put this number in everywhere you see x. So you could put this here, you could put this there. The other option is make your calculator do it for you. And the way you make your calculator do it for you is we're going to graph this function in our y equals. We can get rid of what was here. So we're going to type in, and be careful you type it in correctly, negative 3.678x squared plus 527.3 minus 18,807. Now, if you hit graph right now, you're not going to see anything because this parabola, obviously the vertex is over 71, and our basic window only goes left and right, up and down 10 units. So I'm going to go to my window, and I'm just going to ensure that this x value of my vertex, the 71.683, is actually in my window. My window right now, my biggest x value goes to 10. I want to make sure my x value goes bigger than the 71.683. So I can just do something as simple as 75, because it's big, as long as it's bigger than that 71 value. If I hit graph, again, I'm probably not going to see much. I might see just a kind of small piece of this parabola, if anything at all. But that's okay. All I need to do is use that trace button and type in where the vertex is, 71.683. And I typed something in wrong. Oh, I missed an x value. Let me go back here. I forgot to type an x value in. I could see my answer, large negative, didn't make any sense because I need an x value here. Now let's go to the graph and try that again. I am seeing a little bit of my parabola here, not much. Go to trace, type in 71.683. That answer looks better. The reason I knew the last answer didn't make sense, my answer should represent a percent. And when I made the typo and forgot the x, I was getting a huge negative answer. I'm not going to have a negative percent. This answer makes a lot more sense. If you look at the y value in the corner of your screen, it is just over 92%. So I'm just going to type in like 92.2. What that means is just over 92% of the people said they felt comfortable at a temperature of 71.683 degrees Fahrenheit. So in this case, you're still finding the vertex, but your vertex, that point, actually has a meaning. For parabolas that open down, it's a maximum value. If it's a parabola that opens up, it represents the minimum value of something. So it shows you an application for all of this parabola work that we were doing.